So we're not going to start anything like terribly new today, but there are a couple things that I want to talk about. And then it's just practice. There's no homework. It's just the classwork practice. You should easily be able to get done in class. Go ahead, babe. So slope-intercept form of an equation is what? What is the slope-intercept form of an equation, Bennett? Y equals mx plus b. Okay? Y equals mx plus b. What does it mean to be dependent, and what does it mean to be independent? Tara? Perfect. Independent is where something can just kind of be by itself, doesn't need anything else, doesn't need anyone else, and dependent things depend on others, right?
Can there be two dependent?
Well, yeah, a brother and a sister who live in a house. Y'all are essentially dependents, right?
Yeah.
Y'all are dependent upon your parents to provide the home, the food, all that kind of fun stuff.
All dependent because she moves on her legs to work.
Yeah, but that's not really the way we want you to think about it. Your parents are considered independent because I can, as an adult, decide I'm done doing what I'm doing. I don't want to do anything, and I just move. Done. I can walk away from everything I have and just go do something else. No problem. Y'all can't necessarily do that. Cameron? Technically she would. Technically she is. Yeah. I wouldn't, bring it up to her very often. But yes, technically, yeah. Like if your dad were to ever say, you depend on me, then things get, that's like when fireworks happen. It's terrible. But I have made little comments to my wife before about like, she's like, well, I work too. I'm like, oh yeah, thanks. So we can buy 2 gallons of milk and a loaf of bread. And then about 2 hours later, that's when I'm going back going, I sincerely apologize. That was terribly rude. That will never happen again. So, yes, sir. Wow. Let's use a big word. Telekinetically? Okay. Okay. All right. So independent, dependent. Now there's an application to independent and dependent in mathematics. There is an application to independent and dependent in mathematics. If you were to ask me to tell you what algebra is the study of the relationship between the x and the y. It's the study of the relationship between the x and the y. That's all it is. The entire year. Just talking about x guys and y guys and the fact that they're matched up. An ordered pair is simply a connected x and a y point, right? Gavin?
If algebra is the study of something, it's going to be like algebrology. Because usually, like, the study of something.
No. Yeah, no, that would no. Okay, so now here's the interesting thing. And this is where the slope-intercept form of an equation, becomes something that's useful. The x and the y, and I only want you looking ahead, looking up here. The x and the y, one of them is an independent variable and one is a dependent variable, and I would like for you to tell me which one is which with an explanation. Nolan?
The x is the independent variable. Well, okay, wait, can I start with the y?
Yes?
Okay, the y is the dependent variable because it relies on the x to give it an output.
That is perfectly said. Perfectly said. The value of the y depends upon everything that's going on over here. You create an x value. Doesn't matter what it is. Like if you're making a table, 0, 1, 2, 3, you can just make up your x values. You plug them into the equation, math happens, and it spits out your y value. The value of the y is dependent on the value of the x. That makes the x the independent variable and the y the dependent variable. And when you're given a graph, and it says, which of the following represents the independent part of this relationship? Well, the independent is your x, so whatever this is labeled is the independent part of the relationship. What I need you to understand and lock into your head is that difference between independent and dependent. Independent being your x value and dependent being your y value. Any questions on that? By the way, it's why we always try to put it in slope-intercept form. So because it's so important that we can put it in slope-intercept form, today we're going to practice getting it in slope-intercept form. We've already done a little bit of this practice, but now we're going to kind of raise the stakes a little bit. What if you end up with something like this? Y minus 3 equals 1/2 times x plus 5. And I said, put this in slope-intercept form. What would be your first step, Alex? No. Brendan.
Y negative 3y. No.
I wanted you, what you should have done, Alex, I want you to describe what's being done, not the outcome. You want to go and tell me again?
Yeah. Combine like.
No. No. What's the word, Bennett? You distribute your half to the two terms inside. Your first goal is always to get rid of parentheses. Now, we can just move those parentheses and get them out of the way completely. There's no math to be done. 1/2 times x is 1/2 x. 1/2 times positive 5 is plus 2 1/2 or 2.5, right? And then the last step to get it in slope-intercept form would be to do what? Christopher, what would be the last step to get it in slope-intercept form?
Add 3.
Add 3 to both sides. Now, you cannot add 3 to the x guy because they're not like terms. So you end up with y equals 1/2 x plus 5 1/2. Now, any questions on how I got that? So then here's my question. If I were to ask you to describe this graph, there are 3 things you can tell me, you should be able to tell me about this graph. Cameron, give me one thing. It is relatively flat. It is flat. Claire. He just says flat. So what does that mean? That's not a description. I want a description of the line when graphed. Tara, it is an increasing line. It is an increasing line because it has a positive slope and it's relatively flat. Gavin?
The slope is 1/2 and the y-intercept is.
That's not a description. You're just spewing out numbers. I want a description of the graph. Leilani.
It's the cross over 5.
Crosses the y-axis at 5 1/2. That means, guys, basically, without really graphing it, without ordered pairs, you know it crosses about right here, and it's going to look probably something like this. Right? Something like that. Bennett? Because one of them is an x guy and one's a number. So Bennett, like here, if I were to ask you, what is x plus 3? No, it's not. It is x plus 3. One is an x guy, one is a number guy. You cannot add them. Go ahead. That would be a different thing. Yeah, that would be a different thing. Yeah, that would be a different thing. Tara? Yes, and one of them is subtraction, and one is multiplication. You can't just magically make multiplication out of subtraction. Okay? So you should be able to say that this is relatively flat because the run is more than the rise. So it's flat, it's increasing, and it crosses at 5 1/2. What if I gave you this line? Describe. Maya? It's decreasing. Who has an answer? Jackson? Good. And Nilu? Very steep. Crosses the y-axis at -1. It's decreasing and very steep. Nolan. What do we call it? If I remember, the guys that were over there, we were talking to over there. Tara? No. the what? Jackson. Yeah, this guy is called the linear parent. Now, he's called the linear parent. He's the parent of all lines. And by the way, it never changes. This is the only linear parent, period, end of story. And what's its slope? What's its slope? No. So rather than, yelling out, I'm aware, so you know. The slope is 1, which means it goes up 1 over 1. When you're describing a line as either steep or flat, you are comparing it to this. There are some lines that when you graph them, they will be exactly the same steepness as the linear parent. So you would say it is neither steep nor flat. Okay? Huh? Well, because there's also one that looks like this, Andrew. Brendan? Really? Yeah, y equals negative 1x is not the linear parent, but from a steepness standpoint, it's the same steepness. You can put that. I would take that as a good answer. Okay, so here's what you're going to do. I've got a worksheet with just equations. All you're going to do is maneuver them in slope-intercept form. You're going to describe the line in 2 ways. You're going to describe it as increasing, decreasing, vertical, or horizontal. Remember, you also have horizontal and vertical lines. If you're ever not sure, make a table. If you're ever in doubt, make a quick XY table, create a few input values, stick them in your equation. That'll create your Y values because it's dependent, and then you can describe the line. So you're either going to describe them as increasing, decreasing, or neither. Increasing, decreasing, horizontal, or vertical. These are in the instructions. And you're going to describe it as steep, flat, or neither. Yes, sir.
So you put horizontal and vertical instead of undefined.
Yeah, horizontal and vertical instead of undefined and 0. And the reason is, Nolan, that's a great question. Because if I were to say find the slope, you would say undefined or 0. But if I say describe it, kids won't know. Like if you were to go tell a kid, that line looks undefined. If they're not in this class, they're going to have no freaking idea what you're talking about. But if they say that line is vertical, they would understand what that meant. Yes?
Parabola?
No, that's next year.
A parabola.
A parabola.
I remember we were looking for it up there. Yeah, we were looking for it. Yeah, it's not terrible. Yeah.
Well, and if you think about a parabola, I'll just spend like 2 quick seconds on this. If you think about the way x's and y's work, remember I said that when in doubt, you can just make a quick table, right? So let's make just some quick input values. Let's do -2, -1, 0, 1, and 2. These are the x's and these are the y's. So if we plug in -2 into this equation, what is the y value? What's the output? 4. Very good, Jaden. It's 4 because -2 times -2 is 4. What does that make the y value for this one? 1, 0, 1, and 4. It basically makes everything positive on the y side. And if you think about a graph, that means that instead of going into negative land on the y, it comes back up on the positive. So you end up with like 0, 0, -1, 1, +1, 1, -2, 4, +2, 4, and so on. And so it just has matching sides that go all the way up. 3, 9, -3, 9. 4, 16, -4, 16. And the reason it curves, can someone explain to me why it would be curving? Why does it curve, Alex? Speak in real terms and tell me why it's curving. I'm saying stop trying to impress me, just break it down. Why is it curving? Mm-hmm. That's a good way. I'll take that. the y value is increasing faster than the x value, right? Because it's 2 times 2 is 4, then it's 3 times 3 is 9, and it's 4 times 4 is 16. And as that y value is increasing faster, it has to curve to keep up with that acceleration.
Acceleration.
Yeah.
Thank you for simplifying that information.
You're welcome. Oh, and by the way, every time you bounce a ball, you make a parabola that's inverted.
Oh, yeah. Yes.
And so what you find is for most word problems, the way that you know on an algebra test, if the word problem is a quadratic word problem, is it usually involves you throwing something through the air. Because the force of gravity, it goes up, and then it comes back down at the same rate. Okay? So like, there's a really famous, not a famous, I guess that's a little bit exaggerated. There's a test question in quadratics that I made up that involves you taking a bunny rabbit and throwing it off your roof.
Yeah.
And the girls all go, what? And the boys all go, cool. And they have to determine mathematically when the rabbit hits the ground and meets its end. And that's the end of the parabolic. Do what? Me? No. Although I do like trains.
Oh, wow. What? One day goes into another train.
Oh, different engineer. Sorry. I thought it'd be cool to wear the overalls and wear the funny hat with the whistle.
Yeah.